Hey, the topic today is integration by substitution. This corresponds with section 5.5 in our textbook. Integration by substitution, or U-sub, is really, in my mind, integration's answer to derivatives chain rule. So, when you're doing derivatives, you do chain rule, you identify an outside and an inside. For integration, U-sub, we also start there for identifying an outside and an inside. So let's just kind of get right into it, take a look how this works. So looking at example 1a, so indefinite integral of 2x, quantity x squared plus 1 to the fourth dx. So looking at that problem, can you identify one part of it that is some form of the derivative of another part? It won't always be an exact match, but if there's some relationship, one part is some kind of derivative of the other part. Looking at this, we see the x squared plus 1 and the 2x. Derivative of an x squared is an x to the first. So x squared plus 1, let's call that our inside. And we are going to make that our u value. So u equals x squared plus 1. Alright, when you take the derivative of x squared, you get an x to the first. It doesn't have to be an exact match, but this is some form. Okay? So take the derivative using implicit differentiation. So du equals 2x dx, the plus 1 goes away. Now solve for dx, so du over 2x equals dx. And then chain rule, U-sub works by taking all this work, take the first line, the u equals, and the last line, the dx equals, and substitute those into your original problem. So indefinite integral of 2x, quantity u to the fourth, dx over 2x. And if you do U-sub correctly, magical things happen. So look at the problem we have. The 2x in front, the 2x in the bottom under dx. Those quite nicely cancel out. You're left with integral of u to the fourth du. And by now you should know how to take the antiderivative of this. So 1/5 u to the fifth, and this is an indefinite integral, so don't forget, plus c. Then the last step is resubstitute your u value. So x squared plus 1, plug that back in for u, and plus c. And this seemed really simple. Let me make sure I'm good. Okay, I'm good. So for U-sub, kind of the way you identify these problems is somewhere in the problem is some part of the problem, some type, not exactly, but is it a derivative of another part? That other part is then your inside, that's your u, and then go through the whole process. Now, of course, example A, pretty simple, straightforward. You look at B and C also. Then I'm going to go in here to example 2a. So sometimes du dx is not a perfect match. So let's work through how we can navigate that. So again, looking at the problem, we have an x squared plus 1. So x squared plus 1, the derivative of that is 2x. 1x in the front, that's not an exact match, but it's some type of derivative of x squared plus 1. So we'll go ahead and do the u subprocess. So u equals x squared plus 1. Implicit differentiation. Du equals 2x dx. The 1 goes away. Solve for dx. So du over 2x equals dx. Then what you started with, what you ended with, the u and the du, sorry, the u and the dx. Combine those and substitute those into your original problem. So x u to the 6th, instead of dx, it will be du over 2x. Now, like the last problem, something magical still, but not as magical happens. The x and the x in the bottom cancel out. You're left with u to the 6th du over 2. And based upon properties of integrals and the constant values, you can pull out, so the denominator 2 is a 1/2. So 1/2 indefinite integral u to the 6th du. So then 1/2 1/7 u to the 7th plus c. So 1/2 1/7 multiplied together is 1/14. Resubstitute the u back in, so x squared plus 1 to the 7th. Then think about this, 1/2 times c. That's 1/2 c, but c is just some number. So you have some number or 1/2 of some number. So you really don't need the 1/2 on the c. C is representing some value. Later on, when you get into finding more specific f(x) solutions, your c value, you just be consistent with the work. If you distribute the 1/2, solve for c, let's say you get 8. If you didn't distribute, c would then be 16. Nope, switch that around. If you distribute the 1/2, c would be 16. If you don't, c would just be 8, 1/2 of 16. So I think, yeah, that's kind of this section. I mean, surprise, surprise, there'll be a trick also, so that happens. But take a look at all the rest of the examples. Check your work with my completed notes online.